Hey!
Hello everyone, my name is Ryan and welcome to our JavaScript Israel event, which we are going to talk about two subjects. One of them is SolidJS, and with us now is SolidJS creator Ryan Carniato, and the other one is WebRTC by Joseph Wexler. This is my first event, and because we have guests that are non-Hebrew speakers, I will try to have everything here in English. Both lectures now are in English. And so if my English comes out wrong, just keep in mind this is my first event and I am not a native English speaker, so be understanding and bear with me. First of all, I'd like to invite everyone to come and speak. You can see the links here on the presentation, and of course the links are published every now and then, maybe even in here. And you can look at our code of conduct, of course, but I'm sure everyone just be nice, be polite, and everything is okay. Also, I would like to thank our gold sponsor, Trucks, that are with us for a very long time, especially in these hard times. Very round of applause to Trucks and to our silver sponsor, Pecan AI. Also, thank you very much. Let's talk about some news, things that's happened from our last event. So a little bit about ES 2022. I'm sure you're all familiar with the hash sign for private methods, private fields of classes, I'm not sure everyone has heard about the class's static block, which comes out on the ES 2022, which if you have some code that needs to run prior to class initialization, first of all, first you need to run it outside the class, and now you can actually have a static block inside the class, which is great. Also, I'm sure you've all heard about fetch that are coming to inside Node. No need to import Node fetch anymore if you like to work with the fetch API, which is great as well. Something outside the JavaScript and Node areas. Have you heard about Mermaid, that allows you to include diagrams on your Markdown files on GitHub, which is great. I would like to invite, without any further ado, I would like to invite our guest from SolidJS, Ryan Carniato, to speak about Solid. Hello, Ryan. Good morning, Ryan. Can we hear you? I can't.
Sorry, I was on mute. My bad.
Great.
Hello. Good morning.
Hello. Good morning.
Well, for me at least. I believe it's evening where you were at. I'm excited to be here and to talk about SolidJS.
All right.
So let's get this started. All right. Today, I'm going to present an introduction to a JavaScript framework called SolidJS. This is a framework like many others. It's a declarative JavaScript framework for building user interfaces. And that should sound familiar because it kind of is. My name's Ryan, and I'm the creator of SolidJS. Today, we're going to cover everything you need to know to get started. But first, I'm going to start where I got started. So let's get right to the elephant in the room. Why would I build another JavaScript framework? Truth is, I've been working on this for quite some time. Development started back in 2016. And for context, this is around the same year that Svelte was created. My goal back then was to kind of bring back fine-grained reactivity, which we'll cover in this talk. I was a big fan of a older library called Knockout.js, and I'd grown accustomed to the patterns of using function components and building UIs from these composable, small, reusable behaviors. And honestly, I didn't believe the claims about the virtual DOM. They kind of confused me. I knew that reactivity was performant. So I thought maybe we just need to attack this a different way. So I attacked it, and I attacked it, honestly. By mid-2018, Solid had topped the JS Framework benchmark, JS Repaint benchmark, UI bench, Circles demo, basically every benchmark I could possibly find. But honestly, that performance alone isn't enough to really promote a different framework. And I was still just happy playing along, doing my little experiments. But in fall 2018, everything changed. Yeah, React hooks. React hooks were an industry-wide game changer. Not only in React, where they enabled composition patterns that weren't available previously for the framework. They changed the way the whole front-end ecosystem looks. We see this inspiration in Vue's composition APIs, Svelte built-in syntax. They had a huge impact. But the funny thing was, they look a lot like reactive primitives. So really, since the first time, since Knockout.js kind of faded out into obscurity, I felt maybe someone would be interested in this framework that I've been crafting. Just to show what I mean, on the left, we have some Knockout.js code, and on the right, we have some React. Minus some liberal use of modern syntax, the Knockout has pretty much remained unchanged since 2010. Honestly, if you were using CoffeeScript back in 2010 like I was, even the modern syntax was kind of there back then. You can kind of see it, right? You have some state, which is observables in Knockout, use memo, pure computed, and computed use effect. There's a different analogy here between these different paradigms. And Solid just continues that tradition. As I said, React hooks caught on everywhere, really quickly, in fact, not just the React ecosystem. This tweet I kind of picked up, it was literally 2 days after the React hooks announcement, where Rich Harris, the creator of Svelte, suddenly envisioned Svelte Street's reactivity as a language, right? It was a great set of tweets because you could actually see the thoughts unraveling in real time as he went from looking at React's, explicit structure to thinking, hey, we're a compiler. We can just make this right into our language. It was released later in March 2019. And Evan You announced shortly after the hooks announcement that they would be exposing their reactivity in Vue 3. And it came out as part of the composition API back in September 2020. I've already mentioned Solid was already doing this, but even further out, like Justin and company over at Lit have been working at trying to standardize hook-like behaviors for web components. Not to mention libraries like Augmentor by Andrea Giamacci, Web Reflection, that bring React-like hooks to pretty much any renderer. Basically, in one fell swoop, the whole world had changed. Well, it's probably a good time to introduce reactivity since that's going to be the star of our show. I love this comic because the answer is often pretty elusive. Reactive programming means different things to many different people. So for the sake of this talk, I'll try and take a high-level stab at it, at least what it means to me. The way I think about it is like a live system of equations, like a spreadsheet. See, when you have a normal assignment, it represents a moment in time. What I mean by that is like at the completion, a variable A reflects the current sum of B and C. If either B or C change, you need to do that assignment again. The relationship does not hold through time. However, with reactivity, it does. When you write a reactive expression, it means that A will always reflect the sum of B and C, even as B and C change. So what we have here is really a declarative system, one where once relationships are set, they are just set once and then they execute. You describe the behavior rather than kind of the steps of the implementation. And because these are based off primitives, like simple constructs, they're easy to wrap up and extend. They're modular. You can just kind of build and compose on top of them and get more advanced behaviors simply by kind of piling them together. But the coolest thing about fine-grained reactivity, or what I'll be covering here, and is kind of the language kind of shown throughout this talk, is that you only really need to know about 3 things. You need to know about the observable state, or signals as I call them, which are the atomic data that is tracked. You need to know about computed values, or derivations. In Solid, we call these memos, but these are pure computations built on top of that state. And finally, you need to know about the side effects. That's where the state would affect the real world. I sometimes call these reactions as well, but essentially, this is where the changes actually reflect, in your view. We're going to focus on these primitives for the next few slides. The first one are signals. These are our basic primitive. They're not really much more than a wrapped value from an API surface perspective, right? They take different forms in different libraries, but there's always like this getter-setter mentality. In Solid, we return an array that we commonly destructure, like in the example here, where the first value is the function that reads the value, and the second is a function that sets the value. So as you can see, it's really just a getter, setter, and a value. In the simple example, I'm just console logging by calling the function and reading it, the count, which we initialize to 0 at the top. And then if I set a new value, I can read it there. The truth is, these are found in almost every framework in some kind of form. You might have seen them as observable, or ref, or atom, or behavior. But essentially, there's this idea of trackable reactive state. However, these signals would be uninteresting if they weren't for the existence of other primitives to go with them. Effects are probably the most noteworthy because they're the ones you see. You can see in our simple example, we've taken our count signal again, but now we've wrapped our console log in what I'm calling an effect or a reaction. In some frameworks, they're also known as auto runs, like in MobX, watches in Vue, or computeds if you go back to Knockout. But essentially, with our effect, we run it once, and it logs the value. In this case, the count is 0. But then, every time we change the signal, it reruns that effect. So it calls that function again, and we get the console log. So as you can see, you set count to 5, and then it consoles out, or logs out, sorry, the count is 5, and set it to 10 and does the same thing. This is very powerful because you just set that behavior once. But this also might seem a little bit magical. So I'm going to take a moment to kind of show in a basic sense how this works. At the simplest level, signals are event emitters. They hold a list of subscriptions and can be subscribed to like any event you've ever used. Think like a click handler in the DOM. But these are also primitives you sort of pass around. So maybe a promise might be a better comparison, right? You can attach as many thens onto the end of a promise, and when it resolves, they're all notified. But the magic here with a fine-grained reactive system, like you find in many frameworks, is that these subscriptions sort of automatically happen for you. It looks, as I said, a bit like magic, but it's actually a fairly simple mechanism that you could show in less than 50 lines of code. Basically, by intercepting the read and write and using the runtime stack, we have all we need. So in this simple example here, you could pretend this is an implementation of create signal. Essentially, there's subscribers, which is a set, and then there is a read and write function that we return. The processor read is we check if anything is listening. Is there any current observer, which I'll get into in a moment. Then, if there is one, we just add it to our subscription list and return the value. On the right side, we just set the new value, and then we notify those same subscribers and let them re-execute. The other side of the puzzle, and kind of what's missing here in my first example, is on the effect side, where you can kind of see now that getting our current observer is really just a stack where we keep the context. And every time an effect runs, it just does the same process. It basically runs some cleanup, pushes itself onto the stack, then it runs the function that was provided to it, and finally pops itself off the stack. The effect context in that stack is always available to any signals that read under it while they're executing. This kind of creates this automated cycle of registering subscriptions and doing updates on change. That's basically it. That's the whole trick. As long as you run the effect once, it reads all the underlying signals and is subscribed to them. And then when those signals update, it just knows to write them out and notify them. And all the effects run again, push themselves onto the context, recreate their subscription list. That's all there is to it. And well, not quite. There's one more primitive, remember. I saved this one for last because it's arguably the most complicated. And that's derivations. Because they're both an observer and a signal. And they only recalculate when the value of any dependencies change. In some frameworks, they're known as computeds, like in Vue or MobX, memos, like we call them in Solid, or sometimes selectors. It's a similar concept where you have this sort of stored intermediate value. In our example here, we have a first name and a last name. And then now we have a full name, which is derived from first and last name. From there, we can use full name just like any other signal in our effect here. So it logs the full name as John Smith. If I change the first name to Will, it will update that full name and it'll log it out again as my name is Will Smith. That being said, from this example alone, it's not really clear what the benefit is. You could have just used the signals directly. There are reasons for using derivations. Mostly that they can cache expensive computations, things that you don't want to recalculate over and over again. And this can happen often when they're used in more than one place. You know, makes you think of spreadsheets or maybe calculating tax and tip off some kind of shared subtotal. This happens in Vue code all the time. Different visual representations of the same data. For example, picture you had that full name and maybe that's what you show in the title bar. But when you're sending a message to someone, you know, maybe notifying them of their action, you might use their first name. Or how about that avatar in the corner? If they have an image, that's great. But if they don't, maybe you show the first letter of their first name. These are all different representations of the same data. Another example is kind of like what we saw with the first name and last name feeding into the full name. You can have multiple dependencies. And just because one branch recalculates, you don't want to recalculate the other branch. These kind of convergences of different signals and transformations happen all the time when you're templating in Vue code, like when you're writing out your templates or your JSX. Basically, what can be derived should be derived. This removes potential of getting out of sync, but it requires some bookkeeping typically. And that's what the reactive system automatically handles for you without wasted work. I'm going to show a quick example to show what I'm talking about here. Let me see if I can get this way. Yes, here we go. Our first and last name example. Hopefully everyone can see this. And essentially, I just threw it in here. And I just wanted to show by placing some well-placed console logs where and when things execute. Essentially, the code starts setting up our signals here, and we just log create signals. And then we create our reaction. And if you notice here, I am not using a derivation or memo. This is just a function for calculating the first name. So I want to first show what happens when you don't use a derivation. Essentially, it's just a function. When we get to our effect, however, and we are actually logging the full name, which is just this function, you'll see what happens. Unsurprisingly, it will log first, creating, updating full name, and then it'll log our effects. So you see creating, updating full name. My name is John Smith. Creating, updating full name. Your name is not John Smith. And then when we set a new name to Jacob, well, we trigger these effects again, and we go through the same process. Creating, updating full name, Jacob Smith. Creating, updating full name is not Jacob Smith. Because we're just calling these functions, and we're not storing anything. However, if we take the same example and add our derivation or create memo in the Solid's case around full name, well, the execution is a little bit different now. We create our signals, but when we create our derivation, it runs the log at that point because that's when it calculates it. It goes, oh, creating first and last, or creating and updating full name. However, now when we run our reactions, because we've already ran this once and we have the cache value, it does not. So we only see my name is John Smith, your name is not John Smith. When we go to update the first name now to Jacob, it does rerun it once, but it only once. And then you see the updated effects here. Essentially, instead of running it once per each effect, like we would have just using functions, by using derivations, we have stashed the value and only calculate it once on change. That's the basic idea here for derivations. I got one more example before we move on, though. If you've been paying attention so far, you might be thinking, this looks a little bit like React. But there's one stark difference. There's no dependency arrays. That's because we're using these get and set functions with the ability to track exactly what dependencies are at runtime. And that's without a compiler or some special compiler. You might have seen things like React Forget, which are working towards using a compiler to detect this. And without any manual work from the developer, setting dependency arrays. And actually, this is a very powerful approach because it's not just that there aren't the dependency arrays. We can do more dynamic things with dependencies as they change. So I've taken our last example and updated our full name to be a display name. What we added is an additional signal now to toggle the showing of only the first name or the full name for our display name. At first, this might not seem terribly interesting, but it actually has a big impact on how things run in our system, which I'll show next. So we're back here again. And as I showed, we now have a new signal for showing and hiding the full name. And now our display name memo or derivation basically toggles based on if we're showing full name, or if we're not showing the full name, just show the first name. Otherwise, show the full name here. And we still have our log to console. But there is a bit of a difference here. Initially, we set show full name to true. And for this reason, when we create stuff, immediately the effect runs. It goes, my name is John Smith. So we see the full name, first name and last name. When we set full name to false, well, then we see my name is John, right? Only showing the first name. However, right now, we're just showing the first name. When we change the last name at this point, you don't see a console log because if you look, when we last ran, we only returned first name. Nothing is listening to the last name. So even though we changed the last name, it doesn't cause a re-render. It doesn't cause an update because no one cares about it at this moment. If we change it back to full name true, we do see the updated value. But this is very powerful. It's not just because we stashed the value, but if I went as far as actually logged, let's say display name here, what you'll see is that in this case, running top down one more time, we run it the first time, and then we spit out my name is John Smith. When we set it to false, we also run it, and we see my name is John. However, when we change the last name, it doesn't even run this derivation because it's not listening to it. It jumps straight to, and then when we set the full name to false, it runs it again. So just to get the power here, it's not just that we don't have to explicitly have the dependency arrays. They can actually change with time based on your program usage. And this can save a lot of extra work. This is not something you can do compile time. So having a reactive system is a great way to maintain state. But eventually we're going to want to render the DOM. And Solid's approach to templating actually reflects the same primitive approach that we've been taking with reactivity. Yes, we use JSX. JSX was created by Facebook for the UI library React and is an XML syntax that lets us describe our view inside our JavaScript. Neither Node nor browser understands JSX, so this requires a compilation step. But the benefits are immense. It gives us convenient syntax over the DOM that fits very much with what we are doing. It's composable, it's portable, just like our reactive primitives. Normally, JSX transforms to a number of these kind of create function calls with this sort of expectation that you're going to rerun that whole function or component and call these all again to kind of create some kind of virtual structure. This works well with React, which renders a virtual DOM. It generates a bunch of JavaScript objects and then diffs the new ones against the previous ones to decide how to update the actual DOM. However, we don't benefit from using JSX the way React does. It was designed for a system that executes these functions over and over again. And as you can see here, this is a perfect example of how React works, or Preact, or many variations. It's just a create element call, around our H2, and then it will have some properties, and then it'll insert the children. However, for reactive JSX, we have to compile things slightly differently. We look at it more like a template that generates real DOM operations. As you can see, this is not unlike these console log examples that we've been working with this whole time. Now, instead of logging in our create effect, we just set some text on a DOM node. We're still creating our element, except we're using DOM APIs, and now our effect literally just listens to count, and whenever it updates, sets the count on that, or sets the text on that element. This is super powerful because the function only reruns on change, right? It only reruns that one function here. No creating new nodes, no diffing them against each other, just updating the DOM, pinpoint updates, and really unmatched performance. So let's look at some actual Solid code. This is a simple counter, but I like this example because it is nothing simple for a library like React to create this example. Dan Abramoff wrote a great article on that. And it shows the fundamental difference in approach. So I'm going to actually pull up some live code here, and we can actually look at this example in action. Sorry, this way. Here is our counter, same one I just had there. We have an H2, and I'm going to reset this so we can see it. And essentially, we initialize some state, and then we create an interval, and then at the end, we're going to clean up our interval when our component amounts, and then we just insert inside our H2. And as you can see, unsurprisingly, it's updating. But one of the biggest differences here, and why we can just do that without using like a use effect, is that in Solid, the component runs once. See, I've console logged high here, which will run when the component initializes, but even as the DOM's updating, there's only this single log. And the reason for that, we've already seen before from the code, is we just have this one effect running whenever count changes, and it just updates that element in the DOM. It doesn't require rerunning components or doing any kind of diffing. It's just updating that one text element. And this transcends beyond just a simple, H2 DOM element, because as I said, this is an actual H2. If we want to break things out into components, I've created a header component now, and it's our same code that we had a moment ago. We're still console logging high, but now I'm passing the count through a header component, and then the header displays it. And unsurprisingly, hopefully, we only console log the high in the header once. And again, even though we've broken it into multiple components, the only thing that changed is our create effect that we wrapped around this one H2 element. And you might be going, okay, but you passed this as props, or how did you get this props children in here? Well, there's a little secret with Solid's compiler, and I love being able to show this in the playground, is when we create components, the compiler goes, oh, this statement could be reactive, and it just wraps it in a getter, essentially. It's just This is all the magic. This header is component, even though there's a create component call, that it's basically a no-op or just like a pass-through. All it does is call the header function with an object where it's a getter. So we just lazy evaluate. What this means is when we call props.children here, we're just calling count at that point. We've kind of pushed all the access down to the leaves. In so, we flatten the tree. Regardless of how many components you pass props to or wrap them in context or whatnot, it's only the place where the actual DOM updates or where you've created your custom effects that actually are going to be doing any work. And this is a very different mind shift from something like React. But as I said, it's a very powerful one. I've got actually one more quick example here to show what I'm talking about. I've taken our counter and I've made two of them, and I've put them, in here next to each other, and they're updating on different delays. One's 1 second, one's 1.5 seconds, and they're kind of just going off, right? They each have their own state. But with Solid, we could just take our signal state and just hoist it out. Now they're sharing state. It's basically a global state management. This is the power that comes from your primitives and your update cycle not being tied to your components. Solid has one other mechanism that we should probably talk about. Because we're dealing with real DOM nodes, we actually do have special helpers, because using something like list.map would be very inefficient. So for Solid, when using control flows, we actually introduce components. And I understand this is kind of unnatural to people used to using React, but when you think about it, this gives us simple primitives that are already pre-optimized. And pretend you don't want to just show all the items list. You have a paginated list, and you only show 10 at a time. Luckily, someone's already created that component for you, let's say. Maybe all you need to do is import it and then just rename it. This pattern extends and is composable, right? In the same way, your lists become paginated or virtual lists, and your conditionals become layouts or maybe suspense or error boundaries. It's all the same pattern all the way up. And if you don't like Solid's for component, well, it's just a component, write your own. This isn't compiler magic. This is all runtime. Solid transforms to JSX, but everything else is runtime. And that's a reactive advantage, right? Components run once. There's no hook rules or stale closures. Templates compile to real DOM nodes. So this is a really super low abstraction. You can always just dive in and touch the DOM if you want to. And finally, state is independent of components. Component boundaries are for your sake, how you want to organize your code, not for performance considerations. The performance is good regardless. And that gets me to the end here. How do you get started with Solid? Well, we've been playing around with Code Sandbox or Solid's own playground. These are great ways to get started. We also have a great tutorial on our website, solidjs.com, which has 40 different exercises to help familiarize you with Solid's many features. But for starting your own projects, the easiest way is installing from one of our starter templates. This one is bootstrapped with Vite. Vite's great for a very no or low configuration start and scales into what you want it to be. There are many templates of JavaScript and TypeScript, and these produce great single-page apps that can be deployed to like Netlify or CDN of choice. Also, maybe your needs are simpler. You want to static generate. Astro is a great option to use with Solid. It does so by only hydrating, sending JavaScript for the parts that are interactive on your page. So it's great for static site generation. Combined with Solid's already small size, this is a match that's hard to beat for blogs and content sites or e-commerce. And finally, I might not be ready to build apps with this just yet today, but I want to kind of introduce you all to something we've been working on. And that is Solid Start. It's our new full SSR supporting streaming, file-based routing, and with mechanisms for managing data fetching, and is deployable to Cloudflare workers, Netlify functions, Vercel Edge, or your own node servers. This is a new project that's kind of like our Svelte kit or Next.js. And in the next few weeks, we'll be releasing it as a beta with a new doc site. But if you want an early sneak peek, just run npm init at Solid at Next. We've been building demos like it, like our Hacker News, and it's a really cool thing to check out. And that's about it. I started SolidJS trying to prove something in terms of browser performance. But the more I dug in, the more I found. The more ways to improve performance, even on the server, ways to rethink architecture, ways to reduce code and improve performance, and ways to bend the known trade-offs. We all feel like the guy in this comic sometimes. We want to just eat our meat. But innovation on the front end is showing no sign of slowing down. That isn't something to be afraid of. It's liberating. There is no way you can do or know everything. So I know there's a lot of reasons not to branch out or to try new technology. It's honestly forever fleeting, but it's never been easier than now to get started. Thank you.
Thank you, Ryan. It was very interesting. I was actually a little bit mind blown by the primitive approach. For example, the getter for the children, that you don't need to render everything when just little something is changing. So this is great. Also, I can ask you, if I want to switch from React to Solid, from what I see from your talk, just I need to know that I need to be familiar with the create signal instead of use state, right?
That's most of it. I mean, for the simple components, it's that easy, and we've had a great job porting them. But there's a reason why there isn't like a React compat layer or just a compiler that does it, because when you get past the simple cases, there are some things you have to figure out. Because like Solid doesn't have use ref or use callback or like some of the more like advanced stuff. And if you write your logic that way with React, it's not going to work the same way with Solid. Because Solid's model don't need those because the component runs once. But there is a bit of a mind jump that has to happen for people coming from React beyond the basic examples.
Yes, but my main concern when writing React is to prevent the re-rendering, the redundant rendering that occurs every now and then. And what I saw here was, well, it didn't occur. So this was great.
Thank you.
All right. Thank you very much. Of course, if I want to market SolidJS to my managers, to my bosses, so what about existing projects? Do you suggest migration, or it will be too expensive?
Yeah, it is challenging. For smaller projects, you could, but actually at that point, you'd probably be doing a little bit of a rewrite anyways. For larger projects, I would probably attack it at the leaves. Maybe just use Solid for a page or a portion of it. Maybe some people have been using web components. Solid actually has a good support for authoring web components, and they can use that as their entry point. Then they can just kind of stick Solid as a web component in an existing app, and then kind of, yeah. Yes. So, but coming from React, it looks similar. The JSX will be familiar, and porting will be relatively straightforward. However, it is still porting, so it is work. So I think you break off what you can chew and kind of try it and see what you like.
Yeah, but hosting out the members, the fields that the component has, this is great.
Thank you. Yeah. No, I think it is. I've been building with this paradigm kind of back in the knockout JS days, and it's kind of similar mentality. And I just realized, we could apply this to the modern tooling with the JSX, the Vite templates, all the tools we have today actually make it easier to kind of take this sort of approach than ever before.
Yeah. Now, we do have one question from Material 613. Solid sounds great, but is it enterprise ready?
I mean, to be fair, we only went to 1.0 this past summer. I've been working on this for like 5 years to get to that point. And it's mostly because I cared about stability. But biggest challenge for you right now will be ecosystem and libraries. So while Solid APIs, especially on the client side, we're still doing some new stuff on the server side. Everyone is, if you look at even React 18. I will say that our smaller ecosystem does make it hard to jump into maybe some of the biggest enterprise things where we don't have as many pre-baked sets of components. We're running a hackathon right now for 3 months that I forgot to advertise, but essentially we're trying to kind of stir up that community, see projects people are building, and it's at hack.solidjs.com, and we're hoping that's going to start filling in the ecosystem. We have some libraries like Bootstrap, but people are now working on things like Material UI, Carbon components, Headless UI. Basically, we're missing, I say for the enterprise people today, we're missing that really good set of components, but I imagine within the next 6 months that will not be the case.
Great. So only a few months from now, and you will be enterprise ready as well. Well, you can actually join the hackathon and actually contribute. All right. Thank you very much, Ryan. It was my pleasure to have you here. Our pleasure to have you here.